All right, today we're going to talk about proportional and non-proportional relationships. First thing, let's talk about a proportional relationships. Remember, a relation or a relationship is any set of ordered pairs. So a relation is proportional if its equation is in the form of y is equal to kx and k is equal to 0. And the graph passes through the ordered pair 0, 0, which we know is the origin. So I'm going to go ahead and give you the equation for this relation and graph, but then we're going to talk about how we came up with this equation. Well, our equation, we're going to use a template of y is equal to blank times x plus 0. We're going to start out with that each time. We notice that the x, or the domain, is increasing by 1 each time. So let's figure out what y, or the range, is increasing by each time. Well, when we go from 0 to 3, that's an increase of positive 3. When we go from 3 to 6, that's an increase of positive 3. When we go from 6 to 9, it's a positive 3. And when we go from 9 to 12, it's an increase of 3. So we're going to use this common difference as our coefficient of x. We're going to plug it in right there. And then we're going to check it to see if that is the complete function for this relation. So let's go ahead and plug some input in. If we plug in 0, well, 3 times 0 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9, and 4 times 3 is 12. So this alone is the function for this relationship. We wouldn't have to add anything to it or subtract anything to it to make the rule fit our relation. So when we clean that up, we end up with y is equal to 3x. When we look at the graph for this relation, we can tell by the graph that it goes through the ordered pair, which matches the rule for being a proportional relationship. Let's take a look at kind of a real world example here. Let's say that a professional football team is donating to a local charity for each touchdown they score. So on top, we have the number of touchdowns. On the bottom, we have what the donations would be. So the number of touchdowns is actually our input, the x. The donations is actually our output, and so that would be our y. Well, it's asking us to graph the data first. So we're going to plot these ordered pairs on our graph. Well, if you notice, my graph only goes up to 10, and that's okay for the donations, because the donations on the the x-axis can go up by 1. But that's not going to work for our donations on the y-axis. So we're going to have to change the increments on those, or the intervals. And so let's say we're counting by 50, because that'll make it fit on our graph. So for one touchdown, it was $75 donation. So we go over to one touchdown, and there's 50. Halfway up would be 75. So there's our first ordered pair. Our next one is 2 150. So we go over to the 2 touchdowns, and we go up to 150, which would be 50, 100, 150. So it'd be there. For 3 touchdowns, they donate 225. So we'll go over to 3 touchdowns, and we're going to go up to 25, which would be 50, 100, 150, 200, and halfway more would be 225. Next, for 4 touchdowns, they're going to donate $300. So we'll go over to the 4 touchdowns, and we'll go up to 300, which would be 50, 100, 150, 200, 250, 300. Next, we'd go over to 5 touchdowns and up to 375. Well, I know this is 300. This would be 350, so that's 375. When we graph our data, when we put our line through all the ordered pairs, we can see that it crosses through the ordered pair 0, 0. So I know this is going to be a proportional relationship. So we've graphed the data. Now we need to write an equation. Remember, we're using the template y equals blank times x plus or minus blank. Well, Since our Y is the donations, we're going to put D there, and X is the number of touchdowns. We'll put T here. So first thing we need to do is find the common difference. We've already decided that these are going up by 75 each time. So 75 is our common difference, so that's what we're going to be multiplying T by. Let's check it to see if this is the complete function for this relation. So we're going to start by plugging in the input of 1. Well, 1 times 75 is 75, which matches the output. If we input 2, 75 times 2 is 150. 75 times 3 is 225. 75 times 4 is 300. And 5 times 75 is 375. So we don't have to add or subtract anything to complete our function. So the equation for this relation would be D is equal to 75T. We can take this information and find out what the donation would be for any number of touchdowns by just plugging in the number of touchdowns for T. So if I wanted to know how much the team donated after 12 touchdowns, we simply have to plug 12 in for T. So we would have D is equal to 75 times 12, which would be $900. Let's take a look at non-proportional relationship. On a non-proportional relationship, its graph will not pass through 0, 0, and this one will be in the form of y equals mx plus b instead of y equals kx. Basically, we're going to have to add or subtract something to get this function to work for our relation. So if we look at this table over here, x is going up by 1, that's fine. We need to find the common difference for the y, or for the range. Well, from 3 to 2, that's going down by 1. From 2 to 1, we go down by 1 again. And from 1 to 0, we go down by 1. So our common difference on this one is -1. So we're going to plug that in for m. So we have -1 there. Now let's check to see if this is a complete function or not. If I plug in +1 for x, well, 1 times -1 is -1. That doesn't equal our output. So what are we going to have to add to this to make it match our output? Well, we're at -1. We would have to add 4 to it to make it match our output. So let's try that. If we plug in +1, well, 1 times -1 is -1, plus 4 makes a +3. Let's try it for 2. 2 times -1 is -2, plus 4 is a +2. Let's try it for 3. 3 times -1 is -3, plus 4 is +1. And let's try it for an input of 4. 4 times -1 is -4, plus 4 is equal to 0. So our equation would be y is equal to -x plus 4. If it's given to us in the form of a graph, if we think about this, we know that y equals mx plus b is the formula for slope-intercept, where m is the slope and b is the y-intercept. Well, we can look at the graph and find the y-intercept. The y-intercept is -1, -2, -3, -4. So we know that the y-intercept is -4. We know that we can count the slope, or that we could calculate the slope using two ordered pairs. But in this case, let's just count it. To go from this point to the next point on the line, we're going to have to go up 2 and 1 to the right, which would give us a slope of 2 over 1, which is just a slope of 2. So the equation for this graph would be y is equal to 2x minus 4. Guys, I hope this is helpful. Please reach out if you have any questions. I'll be glad to answer them, and have a good one.